Hey guys, let's solve Leetcode 763 partition labels. So you are given a string S. We want to partition the string into as many parts as possible so that each letter appears in at most one part, right? Note that the partition is done so that after concatenating all the parts in order, the resultant string should be string S, right? Return at a list of integers representing the size of these parts, right? So let's take the first example. As you can see in the first example, we can partition the string as a string a substring of length 9 and a substring of length 7 and a substring of this one, right? But in the second example, there is only one possible way, right? We can partition the string in only one way, right? There is no other way, right? So let's take our example. Let's say we have a string a, b, a, and we have a, b, a, and c, d, c, right? We have this character string, right? Then how? So we start from partitioning this, right? So as you can see, let's start from partitioning this at this point, right? When we partition this, we're gonna have a and we're gonna have these strings, right? But character a cannot be in both sides, right? It cannot be in both substrings, right? So this partition is gonna be wrong, right? But what if we partition at this point? But at this point, you can see like a is also in both substrings, right? This partition is wrong, right? So we cannot partition at this point. But what if we partition it at this point? But as you can see, a is gonna be in the first one, and so this is wrong, right? Because as you can see, all of the characters, which the characters gonna be in their right, uh, only in one side, right? So ABA is and CDC is gonna be correct, right? So both of them have length 3 and 3, right? But what if we partition it at this point? What if we partition it at this? What if we have ABAC and DC, right? This is wrong, right? Because C cannot be in both sides. What if we partition it at this point? At this point, ABACD and only C, right? But because C is in both sides, in both substrings, this is gonna be wrong, right? So the only way of partitioning this one is gonna be this one, right? So how do we solve this problem, right? So to solve this problem, the first thing what we're going to do is we need to know the last occurrence of each character, right? So as you can see, for the last occurrence of a is gonna be at index 2, right? It's gonna be at index 2, and the last occurrence of b is gonna be at index 1, and the last occurrence of c is gonna be at index 4, right? At index 5, right? But what if the last what is the last occurrence of d is gonna be 4, right? So we have this kind of thing. So we know like their last occurrence, right? So we start from this point, right? We need to have two pointers. Let's say this pointer and this pointer, and we're gonna have first maximize their last occurrence. That means we have the maximum length, right, of the partition string, right? So let's say we have a, right? The last occurrence of a is gonna be 2, right? So let's say we have 2, and we move, let's say, this pointer, and it's gonna be 1, but the last occurrence of b is 1, right? But the maximum one is gonna be 2, right? So let's say we move to this point, the last occurrence of a is gonna be 2, right? So at this point, as you can see, um, our maximum partition length is gonna be 2, and our pointer, our index, is gonna be at this point. So we can say like we can this is a correct, right? It's gonna be a correct way. We can partition it at this point. So we have found our last, the maximum last occurrence, right? The maximum last occurrence of we have found our maximum partitioning lengths, right? So at this point, we can say like we can just the maximum, the difference between these two pointers, right? We can say the difference between the two pointers plus 1, because it's zero index. The difference between this, the left pointer, the one which this pointer, and the one we have here, their difference plus 1 is gonna be our appended to our answer. So 2 plus 3, 1 is 3, gonna be 3. Then we will start from this point, the next one. So our left pointer is gonna be start from here, and our right pointer is gonna be start from here. And now we will move that. Let's say our right pointer moves this to and one thing what we're going to do at this point is the last occurrence of c is gonna be 5, right? So C is gonna be 5, right? Then we will maximize, and then the maximum is gonna be here 5, right? Let's say we have changed this to 5. Let's say we have 5. This 2 is changed to 5, right? Then our left pointer is gonna be at this point, and our right pointer is gonna be for this point. And now at this point, you can see for the maximum last occurrence of these 4, but 4 is not greater than 5, right? So it's gonna be 4. At this point, you can see like we have the maximum occurrence of this is 5, right? But we are at this index, at the last index 5, right? At this point, we can see like we can take the difference between the left and the right pointer, and add 1, and we will append it. So the difference between the index 3 and index 5 is going to be 2. 2 plus 1 is 3. So we're going to have this answer, right? We're going to have 3 comma 3, right? So I'm going to solve this problem this way, right? So I'm going to use this way, and the time complex is gonna be open, and the space is gonna be open, right? Because we have to track the last occurrence of the indices, the characters. So first, let's define last occurrence. Occurrence, let's say we have last occurrences a dictionary first. So for, let's say, index in each, we have let's say first we need to know the length, right? Then n is gonna be n of s. We're gonna have n, and then what we're going to do is last last occur is just at of the character at index is gonna be index, right? We can say this. And once we have done, let's say we have 2 pointers, the left and the right pointer. Let's say the one moving the fast. Let's say we have 2 moving parallel moving pointers. Let's say let me call them right and left, right? And both of them, let me have right pointer is gonna be in range of n. So, and max partition, let's say max partitioning is gonna be 0 initially. So the maximum partitioning length is gonna be 0. Then once we have at this point, max par is gonna be max of what we have so far, and the last occur of the given character, right? So at this point, the right pointer, right? So it's gonna be s of right. And once we have done this, if max partition length is gonna be pointing to if this is the same, if we have reached the maximum partition length, we can just say like we can append. Let's say we have an answer array is gonna be initially. Then once we have this point, answer is to append the difference between right and left, since it's 0 indexed plus 1, and we will move the left to right plus 1, right? Because we have taken all the characters from the left to right. And once we have done this, we can just return answer, right? So the time complex is gonna be open, and the space complex is gonna be open because we have used a dictionary here to track the last occurrence of the characters. So the last occurrence is gonna be the time complex is gonna be open, the space is gonna be open, right? So let's see if this works for the first given test cases. Okay, let's since it's gonna be max, right? Max partition. Yeah. Okay. Yeah. As you can see, pass for the first 2 test cases. Let's see submitted there and let's see if it works for all of them. So as you can see, it passed for all of the test cases. So guys, if you like this video, please subscribe.